Picture the universe just moments after its birth. Imagine a vast, glowing fog of matter, expanding outward, seemingly unbroken. If the cosmos began as a flawlessly smooth sea of energy, it begs an obvious question. Why didn't it simply stay that way? How did we end up with a universe filled with massive, brilliant galaxies, instead of an eternal, featureless mist fading into the dark? The answer lies in a tiny cosmic imperfection. Space was never a perfectly flat stage. Woven deep into that early expanding fog were microscopic irregularities. A slightly denser region here, a slightly thinner one there. In those tiny, seemingly insignificant shadows, gravity began its silent, relentless work. The crucial point here is that gravity operates as a cumulative force. A region possessing just a fraction more matter naturally exerts a fraction more gravitational pull. It gently draws in closest neighbors, becoming heavier, which only strengthens its outward pull. It's a beautifully self-reinforcing snowball effect, where gravity slowly takes unevenness smaller than an atom and begins forging monumental structures. But gravity doesn't snap matter together instantly. On a grand scale, it's astonishingly gentle. Imagine a steady drip of water slowly filling a vast empty bucket. Each drop feels insignificant, yet give that drip a few billion years and the accumulation becomes an undeniable ocean. Gravity is the grand architect, but deep, staggering cosmic time is the essential multiplier required to finish the job. This brilliantly illustrates the slow, patient architecture of our universe. Nature is profoundly methodical, following a deliberate, step-by-step process. The universe allows gravity to sculpt these microscopic patches without rushing. Over billions of years, these unseen seeds quietly blossom into the vast cosmic collections we observe today. Yet, gravity isn't working unopposed. There's an epic cosmic battle taking place in the dark. While gravity desperately tries to pull matter inward, the very fabric of space is relentlessly expanding, constantly stretching everything apart. Think of leaves gathering in a rushing stream. A massive cluster only forms in rare, calm eddies where gravity successfully wins the struggle against the outward cosmic current. This realization fundamentally forces us to shift our perspective. We have to stop looking at galaxy clusters as static objects or mere cosmic accidents frozen in the dark. Instead, they are dynamic, ongoing events. They're spectacular, billion-year-long gravitational gatherings that haven't stopped. In fact, they're still actively unfolding right now. Within this grand process, smaller structures, like the individual galaxies we're so familiar with, are simply the first draft. They aren't isolated entities floating alone in the vacuum. Rather, they're the crucial building blocks, the raw materials that will eventually be swept up and folded into something unimaginably larger. This growth naturally builds into a true cosmic hierarchy, and it feels beautifully organic. Imagine a sprawling city forming from scratch. First, scattered houses appear. Then, roads connect them, neighborhoods form, and finally, they merge into massive interconnected districts. The universe builds its ultimate structures in that exact same compounding way. In this developing cosmic city, gravity dictates one profoundly simple rule. The rich get richer. Massive structures naturally sculpt incredibly deep gravitational basins around themselves. Any nearby drifting matter, whether it's a gas cloud or entire smaller galaxies, inevitably falls into these deepening valleys, continuously feeding the very structure that captured them. As these smaller cosmic systems drift together and inevitably merge, they're doing much more than combining their gas and stars. They are actively merging their gravitational influence. By pooling their invisible power, they can reach out further into the void, ruling over vaster domains of deep space with an increasingly inescapable grip. This brings us to the astonishing shape of our universe. Matter isn't scattered randomly like dust blowing through an empty room. It's intricately woven into a staggering, interconnected structure known as the cosmic web, a sprawling network of incredibly dense, glowing filaments separated by enormous voids. When astronomers point our most powerful telescopes deep into the dark, mapping millions of galaxies, this is the magnificent architecture they actually observe. Deep within this web, galaxy clusters act as the ultimate cosmic highway interchanges. They form precisely where these colossal filaments intersect. At these massive junctions, matter arriving from multiple directions is funneled together, pouring relentlessly into one singular gathering point over billions of years. It creates incredibly dense metropolises of light and matter. the ultimate cosmic traffic jam. But here's the catch. Visible matter alone isn't enough to construct this architecture. To make the math work, we have to factor in dark matter. It isn't some magical mystery, it's the unseen architectural scaffolding of the cosmos. While invisible to our telescopes, it silently provides the immense structural support required to build and securely hold these colossal structures together without them tearing apart. The profound realization here is that the universe operates with remarkable consistency. The exact same simple rule, matter responding to the gentle, persistent pull of gravity, operates recursively across every single scale of reality. The cosmos isn't just churning out disconnected objects. It's painstakingly constructing intricate, layered systems of organization, scaling from tiny particles to massive webs. When you truly grasp this elegant mechanism, it unlocks a completely new way to look up at the night sky. The next time you see a distant scattering of stars, you'll know you aren't just looking at a chaotic spray of light. You're actually looking at the glowing, active nodes of a breathing, interconnected cosmic web. Galaxy clusters, therefore, aren't strange exceptions to cosmic order. They are its ultimate, most majestic expression. They represent the grand finale of a brilliant process built with infinite patience, a story that started from microscopic differences at the dawn of time and culminated in the most massive structures we can observe. Perhaps the most surprising thing isn't that galaxy clusters exist at all, but rather that the universe naturally builds them from nothing more than gravity, time, and tiny density differences that once seemed completely insignificant. Which leaves us with a lingering, beautiful mystery. As we look out into the expanding cosmos, what other massive structures is gravity patiently building right now out there in the unseen dark?